product of two positive numbers is 48. Find the two numbers so that the sum of the first plus 3 times the second is a minimum. So in an optimization problem, one of the things you're going to look at first is what kind of equation do I want to make? In this situation, you want the sum to be a minimum. So we're going to need to make some sort of equation sum equals. Because if your sum is your y coordinate, that's what you find maxes and mins of. You find the minimum y value, the maximum y value. So the fact that they're asking us to find a sum that's a minimum tells us that we need to write this equation so that it's s equals. Now, the rest of the information, we have two numbers, so we could start off with an x and a y for our two numbers, but we'll need to make that sum equation only have x in it in the end. So we only have one variable, then we could graph it, then we could take the derivative, then we could find the minimum. So we have two pieces of information here. We know that the product of the two numbers is 48. And so we could rearrange that to get one letter by itself. In this case, I happen to get y by itself. You could get x by itself. It really doesn't matter. But once you get one of your variables by itself, you can now create that equation that's equal to the sum. That's an s, not a 5. The sum of the first number, so if we call the first number x, and then we take the second number and times it by 3, so you might have a preliminary step in here that says x plus 3y is equal to my sum. And then we have to substitute the fact that we know that y is equal to 48 over x into the equation, and we get an equation that is sum equals with only one variable. And now we can use the math skills that we have to find out where is that a minimum. Well, how do we find a minimum? Been doing calculus. We find our derivative. We have a rational equation to solve. We set our derivative equal to 0. And the only place that that fraction will ever equal 0 is where the numerator is equal to 0. And solving for x, you could factor that or move the 144 over. You get plus or minus 12. Of course, the question says the product of two positive numbers, so that means that the only possibility is that x is positive 12. And then you could find y as a result of that by plugging 12 into the equation where we had got y by itself. Mm-hmm. If it said the second number was, right, we're finding the sum is a minimum. If it was a maximum, okay, so now if we look at this equation that we made, x plus 144 over x, the reason they said minimum, and you're going to see it in a second here, so I'm going to go to graph, clear everything out here. Beautiful window that I chose. Look at all the beautiful graph. All right, let's try zoom fit. And play around with my window a little bit more and go up to 30. Okay. Now, this graph, as you see, as it gets close to 0, goes up forever. So there would be no maximum. Okay? Now, had we done the first derivative test, right, because you get 12 and negative 12 with your first derivative test, you would put negative 12 on there, you'd put 12 on there. Would we put any other numbers on our? Yes. Which other one would we put on there? 0, because 0 is a non-permissible value. Okay? And if you tried numbers less than negative 12 into your derivative, you would get positive, saying it's increasing, then decreasing, then decreasing, then increasing. Okay? Which matches up with the graph that we see here. I'm going to go window. I'm going to go for minus 30. So you can see the minus 12 on there as well. It is slowly increasing, apparently, until it gets to minus 12. Then it decreases again. And then it decreases again until it gets to minus 12 and increases again. Okay? So this question only has minimums on the positive number. It would have a local maximum at negative 12. Okay? If we were using our graphing calculator here, second calculate, to find the minimum, okay, it looks like there's a minimum on my graph somewhere between here and here, but that line looks pretty flat. It's hard for me to tell exactly where it is. Do you know that with your left bound and right bound, you can use your arrow keys? You see I have an arrow on there. Or you can just type in values, which sometimes I find faster. So if I know that my scale here goes up to 30, I'm going to try between 2 and 25. Because 2 and 25, those parts show that it's going up. My other part of my line just looked flat. And then when I push enter again, it also finds 12. Oh, it finds 12.1. Interesting. Did I type in a number? Oh, did I type a number in wrong? I have 144. So, well, it's actually nicer with the graphing calculator, because with 148, nothing worked out nicely. But had we had 144 in there, we would have got exactly 12 as well. Okay? So we didn't have to do the sign diagram for this one to show that it's a minimum, because the question said find the minimum. The only value that's possible is the positive 12. And so if it's saying find a minimum and the only value possible is 12, it must be the minimum. Okay? So I would like you, now that we've done a couple of these, to try the next one. I'll put the answer up in a bit. It is another volume one. Oh, it's frozen. There we go. Thank you. So our surface area would be the bottom x squared plus 4 sides that are 4xy. Now, I might also write out right away this volume equals x squared times y. I need to make an equation that's volume equals, but I want only one variable. So I have to say, is there an easy way when I look at my other equation to get y by itself, or is there an easy way to get x by itself? And having x squared plus 4xy, it's much easier to get y by itself than it is to get x by itself. So I move the x squared over and divide by 4x and find out that y is equal to 192 minus x squared over 4x. I can now substitute that in for this y, and I get an equation in terms of x only. Simplifying that equation, multiplying things out, I manipulated it so that I could get it in a form that I could just do my regular derivative rule with my power rule. You could do your quotient rule early if you wanted to, but if you can get something simplified to using only your power rule for derivatives, things are easier. So can you see maybe a preliminary step here? If I multiply that x through, I have 192x minus x cubed all over 4. And if I break them up, 192 divided by 4 is 48. And then minus 1/4 x cubed. That equation is really easy to do the derivative of. And that equation is also quite easy to solve. Yeah, there's an open top. I mean, technically, maybe this question could be worded even better to say an outer surface area, because if you have an open box, there's an inner surface area as well, which all right. So scroll down again here, and we get x is equal to plus or minus 8. Of course, it only makes sense if x is positive, because we're dealing with an actual object. You can't have a square base of side length -8 to make a rectangular prism, and then plug it in to find y, and our dimensions will be 8 by 8 by 4 centimeters in the end. Since all the numbers are nice, technically this could be a non-calculator question, so we could solve it all the way. Anytime you get a question like this that is calculator, okay? If you get a question like this that's calculator, as soon as you get volume equals, you could type that into your calculator and find your maximum immediately from your graph. Look how much algebra that saves you. And you have to say, I need to get good at my calculator so that doing this on my calculator is faster than all that algebra. Because if you have a calculator question on your exam and you have the ability to use your calculator, they want you to make that decision, what is faster to do? Is it better to use technology at this point, or is it better to use calculus? Okay? So what the IB course is trying to teach you is you need to know the mathematics behind it, that you could do the mathematics if you needed to. Okay? At the same time, you need to be aware of when is it smarter to use technology to find an answer quickly. And if I have that ability, why wouldn't I use it to find my answer? So having that calculator ability and the non-calculator ability are very important. All right. Cost of falling asleep in math class is a product of, cost C of ordering and storing X unit of a product is, and do you have the extra 0 in yours? Yeah. Yes? Okay, good. A delivery truck can deliver at most 200 units per order. Find the order size that will minimize the cost. We're trying to find a minimum. Oh, no, I won't underline order size. I'm going to underline minimize the cost. What does that mean? We need to make an equation. Cost equals. Is that already given to us? Yes. Okay, so this makes this question a little bit easier than the last one. We already have a cost, okay? And find the order size. So here we go. Oh, I erased something there, didn't I? There we go. So our derivative, really easy to find. You can move that x in your numerator. Maybe you take an extra step here to move that x into your numerator so that you can see the derivative easier. That negative 1 comes in front. You subtract 1 from the exponent. And then that x squared goes back into the denominator. Setting that equation equal to 0 and solving, again, is not overly complicated. You get plus or minus 100. So you need to show algebraically that there's a plus or minus 100 and that the only one that makes sense, again, in the context of this question, is the positive 100. So 100 units per order minimizes the cost. Again, if we did our sign diagram, we could put 100 in there. You would have 0 because it's a non-permissible value as another point. Of course, if you wanted to continue, you could also have negative 100 on here. But for the context of our question, that doesn't make sense. All right, the question I have been excited about is this last one. Yep. Well, in this case, they're giving you the 200 just to show you that the x equals 100 falls within the range. But sometimes you get that. In fact, when you go to apply what you've learned in school and mathematics and chemistry and physics into whatever job you go into, there's going to be tons of extra information, right, that you don't need. Like the delivery truck driver, probably, she might have a name. She might be Sarah. Does it matter? No, but it does matter in your workplace. If you call her the wrong name, this could cause more problems, and then your cost function changes. So there are other pieces of information that you get. You have to decide, of all this information, how do I organize it? What is important? What isn't, right? In high school, we're trying to prepare you for that. So often we don't give you extra information to throw you off right now, just get you practicing with, okay, this is how you solve it, right? But over time, you're going to get extra information that you don't need. You have to make those decisions. What's important for what I want to solve? And in this case, the 200 units per order, just maybe we're checking to see that our value was within that. Okay. Now this last one is designed to have nice numbers as well. A closed right cylinder of base R and height h has a volume of 54 pi centimeters cubed. Now that doesn't sound like it's a nice number, but for this equation it's going to work out for a nice number. Now I'm really excited about this question because this question has lots of easy applications that you can see. Okay? We have a volume that we want, and we're going to try to find a surface area that's a minimum. So your application for this is, do you ever buy things that have a volume in cylinders? Can you give me an example?
Coffee.
You buy coffee in a cylinder? I guess you put it into a cup, but what do you buy that's actually pre-made in a cylinder? Oh, like coffee grounds, right? Yes. Yes. So buying the coffee grounds could be, and I was thinking like, oh, you're going to crack open a can of coffee. I guess they have the iced coffee. A lot of drinks, though, like cans of Coke, Pepsi, they all come in cylinders, not perfect cylinders, but very much like a cylinder. And this is a question that Coca-Cola really wants to answer. They have a certain volume that they want to put into that cylinder. And if you can figure out what radius and what height to make it so that it minimizes the surface area, because the surface area costs them money. They pay for the aluminum. There's not a lot of aluminum in a can, but that aluminum has a cost. And if you can find a way to save 1 cent per can on aluminum, which isn't a lot, but when you make millions and millions and millions of cans and you save 1 cent, that's a lot of money. That pays for your salary, right? And so if we can figure out, if we can re-engineer how things are made to minimize how much we need, that can have a huge effect. And then all of a sudden, you're like, here's my proposal. And they're like, wow, that proposal is going to save us $2 million a year. And you're like, okay, I'll sell it to you for $3 million. They're like, perfect. That'd be a great day's work if you can figure out those things. But that's where calculus and mathematics really comes into play. Now, a can of Coke isn't a perfect cylinder, right? It's not flat on the bottom. It's got like some curvature to it. The top has a certain design to it. How do you, maybe you redesign how it opens so that that little tab is smaller. So all of those things are opportunities that someone, if they can figure out a better way that uses less materials, can save a company a lot of money. And companies like that are very interested in that because they're not going to reduce how much you pay for it. They're just going to take more money from they're just going to make more money. Often in these questions, okay, in the end, we're going to try to find the minimum surface area, right? So we're going to need to make an equation, surface area equals. And often on the exam of an IB exam, they start off with a show that. Because if you can't make the surface area equal to something, you're not going to be able to find the minimum. So they start by saying, can you show that the total surface area of the cylinder is equal to this equation? Well, what do we know already? We know that the volume is 54. And if I know that the volume is 54 pi, and my volume of a cylinder is pi r squared times h. Does anybody know why the volume? Okay, first of all, does everybody have this formula memorized? No. Okay, good. I'm glad someone doesn't have it memorized. Because I think it's one of the formulas that you can visualize and just know by thinking about it. Okay? Here's my cylinder. On the bottom, I have a circle. The area of a circle is pi r squared. If I cut a piece of paper and put it on the bottom, would it fill the whole cylinder? No. But if I kept cutting pieces of paper and laying them down, eventually I would have a cylinder full of paper. What shape do I have? How many pieces of paper do I have? Well, that's my height. And if I keep putting on areas of pi r squared and stacking them up, pi r squared is my base times my height, I will fill that whole shape, and that will become my volume. And so I find that by thinking that way, that formula isn't one I need to memorize anymore. It just makes sense. And if you have things that make sense that you don't need to memorize, that frees your brain up for other stuff. It's not like your brain has only a limited amount of space, but you are able to remember it better. Yours does? Yeah, it's on full. Yeah, it's just, you know, go delete some stuff. Like, do you really need to know Harry's name? No. Delete. See? Perfect. Now you can learn some math. And so if we stick that h and substitute it in, our surface area is the two circles on top plus 2 pi RH. Oh, I love the cylinder surface area formula. That's another one, if you visualize it, you don't have to memorize it either. Okay? The first part, 2 pi r squared, that's the circle on the top and the circle on the bottom. That part's easy. The 2 pi RH and You can visualize this if you go home and you have a can. Do you have any canned soups or canned vegetables at home? Okay. Go home, take off all the labels and see if you see a pattern. Your parents will be wonderfully happy. They go to their cupboard to get something and all the labels are taken off, all the cans. But if you take a label, here's a label on this. If I take this label off, what shape do I get? A rectangle. And that rectangle, when you peel off that rectangle, it has a height, but the top of it is what was originally around your cylinder, which is your circumference, and your circumference is 2 pi r. And so the area of this rectangle is 2 pi r times height. Okay? If you don't have it memorized, go home, take off labels of the cans that you have at home until you're convinced that they're always going to be a rectangle. And if your parents get mad, you just have to say, I needed to do that for my IB math class. It was my math IA. And then it's a probability. What are the chances supper's going to be good tonight? And then part B of this question says, hence, find the radius and height which makes the surface area a minimum. So part A, the show that, already set us up so that we would have an equation that was surface area equals in only one variable. So if I find my derivative here, I've got surface area in terms of radius. I can set my surface area equal to 0. I mean the derivative of my surface area equal to 0. And by setting my derivative equal to 0, I can find the r value that would make it a minimum. And despite thinking that we started with not nice numbers, starting with a volume of 54 pi units cubed or centimeters cubed, which seems like not a very nice unit to start with, that was nice because when everything's solved, we get 3 centimeters for the radius. Yeah. Pi is a number. It doesn't go away because here we have an r squared. So we basically have 6.28 r squared. And then that 2 comes out and multiplies your 6.28, which becomes 12.56, or 4 times pi. So since there was a variable there, it didn't go completely away to 0. And now that you have r is 3, you can figure out what your height should be. So now you could redo this question and replace the volume of 54 pi centimeters cubed with 355 centimeters cubed. That's the volume of Coke or Pepsi in a can. And then figure out what are the dimensions for the radius and the height that I should have if I had a perfect cylinder of aluminum to use. How close do those dimensions get to the actual dimensions of a can? Because it used to be that people would be like sort of guessing and checking. That was sort of the first manufacturing. Let's guess and check. Let's tweak this a little bit. Oh, we're using less perfect. Let's go with that. But now, in our age of mathematics, you don't want to waste time guessing and checking. You want to say, how can we use calculus to figure this out? And especially when they're building things that cost a lot of money. You don't want to do a lot of guessing and checking. Right? We're going to build a new airplane. Let's just guess and check. Right? Oh, that one crashed. All right, 6 people died. Let's try again. Anybody got a new guess? Right? In math, sometimes guess and check's not bad to find something that doesn't work to try again. But in certain situations, you don't want to guess and check. Right?
Does this steering wheel work?
I'm a surgeon. Is this the appendix? I don't know. Let's guess. See if the person survives 2 weeks. No. There's certain times a guess and check isn't a good idea.